but in a prototype you can carry out the testing. Once you are aware, then you can have the aesthetic and all that look and everything, and then you can drop that product in the market for the earning the profits. So basically for a testing environment, we always go for a prototype model. Then the aim of the prototype is to save time and money, because you cannot, like many a times you must have heard that one of a tire reputed tire multi international tire company, they have that is taken the tires of so many that was a news in the paper. Then you must also have heard about the Maruti, that from batch number this to this, if you have already launched the product and then you find that there are some customer complaints, and then it becomes very difficult to replace all these things. So Maruti, again, from batch this to this, they have called all the customers with their car in their showrooms, and again they have replaced some radiators or some problem. So so that's why all designing experimentation has to be done within the prototype stage only. So that will save your money as well as save your time also. So aim is to have something that can be tested with real users. Even nowadays you find that in case of the many of the automobiles also, they normally, many a time you find that the engine remains the same. They are using the same engines, maybe the Baleno engine used for Desire engine used for some other vehicle. But then what, only the, maybe the, that is the outlook of the vehicle is changed, and that is changed just by changing the dies and all things. If you can change it nowadays, you find that every part, even right from a small part which is directly related to the inertia forces, they are all given the aerodynamic shapes. So even the mirror, if you find, it is aerodynamic, so that it reduces the inertia forces, and that's how you can increase the mileage. Then you use nowadays only the chassis, they are using the steel. Otherwise, for maximum components, some plastics or maybe some composite materials they are used, which are very light in weight. And then when we use this type of material, it becomes so easy to give the aesthetic looks, and that's why you find nowadays all aerodynamic shapes has been given. And that's when that is the one after another, the new models, they can easily launch it just by changing the aesthetic looks. Engine remains the same. So the aim is to have something that can be tested with real users. So this is nothing but a prototyping, all of you know. Now see here, what do you mean by prototyping? This is, everyone now know that when wherever you can go for a testing, that is a prototyping. You never get it right first time. So anything, any ideas which normally comes, and converting that ideas into a 3D model will have so many errors, and so it will never be right at the first time. There will always be the redesigning which is required. So basically, if you see this prototyping, it is a design, then comes the prototype, and once you go to the prototype, then you evaluate. And then at the evaluation stage, if there are some feedbacks which is coming, again you come back to the redesigning, and again you come back to the prototype, and that's how your product gets the new improved version. And that's how if it is okay, then the real prototype can be converted into a real model which can be launched in the market. So again, if you see this, what is a prototype? It is the working model or first trial garment of new design to be tested. So the same, because feedback is very important. Without feedback, you cannot say that it is 100% working model. So see a design, build a prototype, then user test prototype, And from user test prototype, see, it is a feedback which is provided, and again it is redefined, that is a redesign stage. And after redesigning, again user test prototype, and then it comes to the final product design. So that's how the testing, everything, experimentation is done at the prototype stage only before. So this is just how the interface from a paper to the mobile or to the this can be taken. Then again here, what do you mean by prototype? So again, going into a detail of types of prototypes and all designing steps. So what I have in the further slides, I have come to the applications, that how we, what are the manufacturing techniques which we will be using to prepare a prototype of model. So now see here, what is a prototype? An interactive design, it can be any of the following: a series of screen sketches, a storyboard, that is a cartoon like series of scenes, a PowerPoint slideshow, a video simulating the use of a system, a piece of a software with a limited functionality written in the target language or in another language. Or it can be a product design, it can be any product like a small bottle, it can be like in a pandemic, so many products related to the healthcare system. All of you are aware that how many, in many of the NITs, IITs, and institutes like at YCCE also, we have developed using 3D printers some of the walls, or maybe some of the components which were associated with the ventilators, or that is the ventilators, or the, that is maybe some other healthcare system. So these new products on the demand were design, or the prototype models were made, and then if it is suits, if it works, then the that is the manufacturing can be done on the large scale over there. So this is just a type of a jar which has been designed using a modeling softwares. So how to build a prototypes here, how to prototype. So build a prototype of basic functionality, especially the interface. Test the prototype, which will uncover design errors, correct the errors. That is very important. That is a feedback system. Correct the errors, and then repeat until you have a clean design. Even nowadays, it's very easy. All of you have are aware of these CAD softwares and everything. But maybe 10 years back down the line, if you even go to the nearby industries like Mahindra and Mahindra, there there the blueprints, all of you must be knowing. Nowadays we directly we are learning, you people have learned the AutoCAD, you have learned the CAD softwares like Proe, CATIA, SolidWorks, all these softwares, and now you have the drawing files in your computer itself. But maybe 10 years down, we were having the drawings which was drawn on the sheet, like the drawing which was used to the machine operators, and then he's looking at the drawing, he used to manufacture the component. And then because that drawing, he used to place it on the machine where there were oil and everything. So there used to have one blueprint of that drawing, so that we call it as a ammonia print. And then that was stored in some place. So whenever you tear the drawing, or some drawing goes missing, then again you take the printout from that ammonia print. And that's how the technology used to work at that time. And then the machine operator used to manufacture as per the drawing dimensions which he was having. And once the product is manufactured, then it used to be fitted on the assembly, and then the assembly, we used to go to testing department, and then in a testing department the loads were applied, and that's how the testing was done. And then it was found that there is some error, or there are some designs, there are some components which were failing. So you either need to change the dimensions of the component, or you need to change the material of the components, maybe use some higher strength material so that it can sustain that loads. So again we used to come to the first step, again to the R&D department. Again the drawing used to get modified, the material used to be changed. But nowadays you find that everything, before manufacturing before manufacturing, everything is done on the that is the prototype, that is on the computer itself, wherein you can change the material, you can change the dimensions, you can change the dimensions, as well as the that is the everything, the forces and all, and you can come to a conclusion, now this is the best one, this is the optimized one. You can see the simulation of it, you can see the working of it, and once you are satisfied, you can carry out the analysis using ANSYS, FEM type of softwares, wherein you can give the loading conditions, and then you can carry out the stress analysis on that until you are satisfied. Then only you send it to that machine operator to do the manufacturing of the component. So nowadays it's so easy to do the prototype, to have the changes in the prototype, and then come to the final conclusion. So so test the prototype, which will uncover design errors, correct the errors, repeat until you have a clean design. So repetition is very easy nowadays, but in the 10 years back, the repetition was, again he used to manufacture every component again and again, and then used to check it. So that was very tedious process, cost consuming was there. So but now you can do the repetition on the computer itself, no need of again and again manufacturing it. So prototyping is improving usability, heavily used in industry. So naturally anyone will try to save the money as well as to the cost. So he will use the prototype. Once he is assured of giving the result, then only he will go for the manufacturing of the components. So this is the journey of the prototyping process. So goals, maybe the ideas, the functionality, the development stage, and then the evaluation. And again through the feedback, again you can come back to the development stage, again improve it, and again evaluate for the final product. So this is the benefits of developing a prototype, a great way to transform your idea into a three-dimensional version of your idea. That is very important nowadays. Also, converting ideas into a product is a very challenging. It's very easy to give the ideas. Even in a classroom, if I say to you that, sir, students, they have so many ideas, but then converting that idea into a product, and that product should be acceptable, then then it's very challenging. So so, and out of thousand, only two three ideas maybe which will be accepted by the customer. So you have the ideas, but then that ideas, maybe it is a innovative ideas, but nowadays innovative ideas doesn't remain for over a year. Maybe within a week, some may have some another idea which is much more innovative than that. So innovative ideas has to be converted into the product. That is very challenging. So it gives you the opportunity to tap into your creativity. So that is always the opportunity. You don't know, so many TEDx talks we have heard. Some many of the entrepreneurs, they are saying that that is maybe the first product may not be give you the success there, it can be the sixth product, seventh product. So you should always try to explore so that the success will always come. So it enables you to test and refine your product. You can test the material to ensure design functionality, helps you sell or license your inventions. That is always a, that is many of we are going, many of you also are going for copyrights, the patents. So it is always that the patent should be attracted by many of the investor, then only the patent has the usefulness. That if it is attracted by many manufacturers or many investors, they should always look for the patent or the invention which we have taken. Creating a prototype for a class enterprise. This is one example where how to create a prototype for a class enterprise. It can be anything for a manufacturing also for a product. Then how to start creating a prototype, maybe right from ideas you can start it. So for here, for example, for a class enterprise, the factors to be considered is cost, funding, skill level, time, target market, competition, and then the county school rules and regulations. So these are, but that always depends upon the product also, where you want to launch it, how you want to market it. For example, I'll just every time I give that example that when I say that uh, क्या चल रहा है, so many of you will say that क्या चल रहा है. So all of you know that that is a punchline. For which product it is a punchline? क्या चल रहा है?
Fog.
Yes, it
Fog.
is a fog. So many perfumes are available in the market. It's not that fog is a unique perfume. But then see the punchline. So then where comes the prototype over here? So many perfumes have such a good bottles, such a wonderful shape of the bottles. But then are we designing over here the prototype for a fog? Are the fog they are that is they are sold because of the shape of the bottle of the fog? No. So here the marketing is, here the marketing, that is the punchline which has made it more popular brand. And that is nothing but market में क्या चल रहा है. So everyone says that fog, and that's how people recognize fog as one of the perfume. And when you have a choice, you directly, because fog every time you heard क्या चल रहा है from the advertisement. So the marketing advertise, that is another sector by which you can sell your product. You can you can, for example, many of even as a student of mechanical engineering, I have seen so many girl students, even after doing the final year, they are not in a position to tell me that where is the lever of the brake, or maybe that brake is called as a lever, or brake system is something different, the clutch system is something different, the clutch lever is there. So so even when we go for purchasing the two wheeler, maybe the bikes or maybe the Activa, so as an engineer we should always talk in terms of the some technical specification. But how many of you even asked it, sir, to the, that is the to the that Maruti owner or the Honda owner, to the, that what is the torque of this vehicle, what is the ground clearance, what type of fuel injection system is used? No, we only, maximum customers, they are attracted by its aesthetic look only. So you never, maybe few of you maybe are attracted towards its CC, because you know that 250 सीसी की गाड़ी बोले तो सारे बच्चे अरे बोलेंगे 200 500 सीसी की गाड़ी है, 900 सीसी की बाइक है. So but then even the manufacturers, they know that it is only the 1% or 2% of the customer who will be asking this technical specification at the time of purchase. So they are more neglecting this 1%. They are concentrating on 99% who always select the vehicle based on the aesthetic. So their main focus is on the aesthetic. They want the the seat covers to be made up of leather, and the dashboard. So you get attracted the AC, then the ducting system, and all these things, which maximum customers, and their focus is on not that 1%, their focus is on this 99%. So that's why that's why when I say that when then where it comes the prototype design. So how many of you really look into the design aspect? So maximum of you, they look for the some other aspect. So we'll move forward. There are some application slides which I have put up. So this is steps to take the research, the market for ideas. These are all the things which all of you, cost of your prototype, that is very important. Cost of your prototype, test your prototype, create a working model, create a drawing of your prototype, brainstorm. These are all, it always starts with an idea, then the rough sketches, the drawing, then the CAD model, and then you create a working model, the each component, then the assembly, and then you work carry out the testing, and then you prepare a prototype, again take the feedback, and that's how you ultimately you come to the cost of the prototype before launching into the market. Now this is just now, no theory has been added, only the slides I have put it, application based slides. Now this is the importance of the sketching. Right now, again, many of you I have seen so many students doing their projects. You never start with the sketching. I have seen people directly they bring the CAD model. Sir, this is the drawing. अरे but drawing assembly है, your project or your any product, it consists of like this slide, it shows the cycle bicycle. Now bicycle has at least 25 different parts. So when you start the drawing, at least you should start, because you are the designer, you should know that which is a rotating part, which is the part which is fixed, from where you will have the turning motion, where you will have a rotary motion. So once the concept is clear, that concept has to be put on the paper. Directly you cannot get a CAD model. But then many of you directly bring, because it's very difficult to draw the rough sketches, and then come to this, that what should be the joint, whether you want a nut bolt, whether you want a type of revolute joint over here, you want some washer over here. Now this is missing nowadays in a when you do the project, because you are not aware of the different components. You only want, sir, this is the CAD model, I have prepared it in Pro E and CATIA and SolidWorks, and then someone will do the manufacturing. But then as a engineer, you should always, at every joint you should know that what type of component you will be requiring, where the bearing will be required, where the sprocket will be required, where the what type of sprocket will be required, what size of bearing will be required. Then at that point, how the bearing to be fixed, how the these are the basic concept of mechanical engineering which is missing. And I'm more afraid during this last 1.5 year, during this pandemic period, many of you, many of the mechanical engineers, without the practical knowledge, without looking at the maximum of these components, just how you people will be coping, so that if you really want to work in the industry, in a manufacturing environment, you should be aware of these all these components, selection of bearings, selection of motors, which is very important, that what type of motor, whether it is a AC motor, whether it is a DC motor, what should be the RPM, whether what should be the, that is the uh, what output you want based on the output, whether it is a 1 HP motor which is required, a 2 HP motor. So all this, that is the reverse engineering, the forward engineering, the gears, the, these are the basic components of mechanical engineering: the gears, the pulleys, the belts, the selection of bearings, the couplings, the flanges, all these things. You should know where this, when you want to design a product, product is not just a stone, like it has got n number of components, and then each component is having some relative motion with some other components. So the importance of sketching before coming into the CAD model, you should have the sketching of each and every component, what you are, what you have your ideas in your mind. Now you have the ideas, but then you don't have the capacity to put those idea on a plain paper. So that is also there. Many of you don't know how to draw the rough sketches, so that, see the rough sketches which has been shown at every point, what should be the connection between the handle and the front wheel, rear wheel, and then the chassis and all these things. Once you know this, then only you can go for the CAD. The concept also becomes very clear when you have the sketching done. So now this sketching can be even done on the softwares also. Then once you this is also known, all of you know this, this is nothing but a CAD model. Nowadays all of you, again 10 years back, a engineer with a CAD, and that is the knowledge was considered to be much superior. But nowadays these CAD models are even drawn by the ITR students, those who have a good vision of 3D environment. They can easily draw the CAD models. So now it is not expected that a engineer, a BE engineer, should do the modeling. Now he can, the BE engineers, he can go for some other analysis, maybe the next version of this model. So you should be very good in modeling right in the second year itself. So you should explore on your own, no need of going anywhere. You should explore. Nowadays it's so user friendly, so that you can easily draw the 2D model, 3D model, explore n number of softwares wherein you can convert the 2D into a 3D models. So this is the advantages of a CAD model. So many softwares are available wherein you can convert a 2D, that is a AutoCAD image, into a 3D model. Then this is again the, before the prototype also you can do the analysis part. Once you come up with the product, you can carry out the analysis. All of you know the analysis, that is the ANSYS, wherein you can, like, this is the first component is the, that is a bucket of that is excavators. So wherein you can easily say that the portion which is red is having more stresses. So naturally that is the point of contact between that lever and the bucket. So when you tilt this bucket, automatically you can easily say that at the tooth also there can be the stresses. The tooth which is dark blue, that can be also, there can be some, like for example, if there are stones in the ground, in the soil, and if the tooth comes in contact, then there can be the stresses on the tooth, and the tooth failure is also there. That is also a concern in designing the buckets. And then at the point of the joint where the bucket is connected to the hydraulic shock ups. So at that point, the stresses, you can see the red color, which indicates that the stresses. So this part also you should always compare. See here, many of I have seen so many projects where students they do the CAD model, they do the FEM analysis, and then they cannot interpret. See, it is a software. It will always gives you two three colors, but then you, as an engineer you should always compare this softwares with the theoretical formulas which we have learned in strength of materials, in the machine design, in the design of mechanical drives, wherein you can easily find out the stresses coming on to that maybe the rod which is you fixed at that bucket end. So and then you can compare that theoretical values which has been calculated using the formulas with the actual values which are obtained using this ANSYS software, and then you can compare it. So once you do it, otherwise what many students they say, they said this has been the report which has been generated by the FEM ANSYS software. So it has been generated, it will generate any if you give the loading to any of the component, it will generate a report, it will show some blue color, green color, red color. But then interpreting it and then comparing it with the analytical values, that will complete your project, and that will also improve your knowledge also. So this is the, that is the crank. All of you know what is a crank. It is a member which is used to connect the piston and the connecting rod. That is the crank and the connecting rod. So all of you know, once you come up with the once the analysis done and you are that is now you are aware that the product, the prototype is perfectly all right, now we can go for the manufacturing, which can be directly put it in the real world. So then the manufacturing technique, all of you know that the CAD model can be through the CNC. All of you know that you have nowadays the what we call it as the subtractive manufacturing, where the material is removed, that is called as the subtraction. And there is another one which we call it as additive manufacturing, where the material is added layer by layer, and that is nothing but a 3D printers, which all of you have seen it. We also have in our lab where a 3D printer, how the layer by layer manufacturing can be done. So there you add the material, so that's why it is called as additive manufacturing. Here in a CNC using a lathe, drilling machine, or maybe the turning, milling, all these operations where the material is removed, you have a raw material and from there you remove the material. So that's why it is called as a subtractive manufacturing. Then again, all as a student you should know all these, that how the CAD model is prepared, now how to transfer this CAD model into the CNC machine, what type of programming it is, that is G code, M code, which you have already learned. So how these codes are generated, and then through the through the that controllers, maybe the Siemens controller and Fanuc controller, all of you, how the that program is given to the CNC, and then every tool it gets operated, and you get the final product. So that is what we call it as a subtractive manufacturing. Then this is nothing but additive manufacturing. So nowadays, what is additive? Using a 3D printer, any complicated part which is not easily manufactured using the subtractive manufacturing can be easily manufactured using the additive manufacturing. So during this pandemic, you have seen that using this additive manufacturing, so many walls, like one ventilator used for 3 or 4 patients through different four-way valve was designed, a three-way valve was designed. So many new invention during this period was done, so that especially in the healthcare system it was done. So so all of you know that this additive manufacturing, it's a future that it will come. It will come. Maximum manufacturing will be done using this 3D manufacturing only. Then these are the basic which again by putting then all of you should know the injection molding process. These are the products, so many products which are manufactured using the injection molding. Many of you might have seen these machines, injection molding machines. But then so many where you have a plastic granules as a raw material which is poured inside that hopper, and then you have a heater, and then through the heater that the temperature of that raw material is increased, and then inside that box you have a die maybe of these components which has been shown on the right hand side. All these are injection molding components. And then as per the product you have to have a die, and then either using the blow blast, or maybe the pressurized way, or you can blow that hot that is the granules, plastic granules into the die, and you can achieve these type of products which are maybe the strength is very low, but then here you don't require the strength. These are the components where like some dustbins are there, some furnitures are there, maybe many plastic components which are nowadays they are manufactured using the dye injection molding machines. So this is another in many in even in nearby our Hingna MIDC you find so many industries having the injection molding processes they are using to manufacture the components. So here these are the dies for the all of you should know that the dies is very important. So all these dies are designed on the this that using the CAD model only. So it is basically in a two half, then only you can remove the material. Otherwise if it is in a one part only, then you cannot take the first one is that is the rubber hot water mold. That is all of you have seen that whenever there is a swelling or anything on the body, we normally use this rubber hot water mold. We insert the water mold, and then we tighten it, and then we place it on the portion where there is a swelling or anything, so that it gets reduced. So that is again in a two half which can be easily removed. The second one is a dies of the that is a Bisleri or the mineral water bottle, wherein again it is in a two part. So again through the that is the hot pressurized that plastic granules will be blown off, and it will again come into this die, and that's how the bottles are manufactured. So many components, thousands of components are there nowadays which are manufactured using this injection molding processes. So so this is again which I want to tell you. The second process is which all of you know is the casting, which is again used for mass manufacturing. So once you come up with a prototype, and then now you want to launch the product, and if it is to be using a casting, it can be a sand casting, it can be a metal casting, like the industry that is the biggest casting which we have in India is the this which one in Butibori, Nico casting. It is one of the biggest casting in India. So they are casting the drainage, drainage, these slabs and all these things. So many products they are casting. Uh, so casting is also one of the major. You have learned the casting in your manufacturing process, one, two, machining process, the different defects used in castings, and so many things which is very important. Then the another Another manufacturing technique for once your prototype is designed is the press working. So many products are manufactured using this technique, which is called as a press working. So manual press, like the best example is the punching, like a punching machine. All of you have used the punching machine where you are applying a manual force over there just to cut the two holes on a plain paper. Similarly, 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 there can be the machine press, and the tonnage can vary from 1 ton to 1,000 tons. So many huge presses are available wherein you can manufacture the component. So tonnage capacity, that depends upon what component you want to manufacture. You cannot have a 100-ton press and then you are only manufacturing a small component. So that will be the wastage of electricity, wastage of machine and cost. So everything. So tonnage depends upon what product you want to press it. What basically the raw material used for the press working is a sheet metal. Anything which is less than thickness 5 become it comes under the sheet metal, and anything whose thickness greater than 5 it comes under the plate. We call it as a plate. So so sheet metals, basically they are the raw materials which is used in the press working machine. So you can see the press working, these are the third one is a press working which is based on the flywheel, and these are the pneumatic or the hydraulic press working machines. And the first image, you can see the different products which are manufactured using the press working. So from the sheet, like the cylinders, LPG cylinders which we used, they are the example of the press working, example of the press working machine. Then this is another important process which all of you know, that is the hot rolling and the cold rolling. All of you know what is the hot rolling. So the hot rolled sheets are passed through the rollers, and that's how the thickness of the sheets it goes on reducing, and it comes to the final sheets which are rolled on or which are coiled. So that is the hot rolling. Then you have a cold rolling. So cold rolling is the cold sheets, they are again passed through the different rollers, and then they are squeezed, and that's how the thickness is reduced. So that is, these are the two. You have a cold rolling plants, you have a hot rolling plants. In Amravati Road, you have the that JSW, that is a Jindal Steel, where they are the largest manufacturers of this. That is the sheet, maximum sheets which you purchase for the roof purpose. It's, you will find that they are manufactured by the JSW only. That is the Jindal Steels JSW. So so this is the another important that is the phenomena in the mechanical engineering, that is the forging. All of you know the forging. To increase the strength, you always require the forged component, because casting and everything, there are so many errors in the casting, so many defects in the casting, and because of that, the that is the material properties, it is reduced considerably in the casting. So if you want to apply the component where the strength is the criteria, we always go for the forging. So forging, all of you know, it is a repetitive hammering on the portion so that the strength of the material increases. That is called as a forging. So this is the forged one. So you can see the first one where the he is applying hammer and putting some force on it. Then these are the techniques nowadays. All of you should know these techniques. That what do you mean by, that is AWJM, that is abrasive water jet machining. So this is how the using the abrasive water jet, using water jet, how you are cutting the metals. So Before this, there were cotton from the cotton balls. That is another challenging task. So many applications you will find in so many sectors, in whether it is a health sector, whether it is a agriculture sector, whether it is a manufacturing sectors. So nowadays, like holding a phone for 2 to 3 hours is a very challenging. So can we have any other arrangement? Nowadays on a road, I have seen some product you can put a phone horizontal, and you can see big screen type like a TV screen of that mobile phone. So such type of innovative products can be always be thought of, and always as a student you should always go for uh, converting that innovative idea into a product. Yes, any other questions?
Filing patents, and nowadays commercialization of patent is a very necessary part or very important factor that we have considered.
Yes.
Now we have taken a lot of initiatives, but what we found that in a current scenario, product development plays a very important role, because there are number of ideas which appear in the mind of the student faculties, but that idea doesn't reach, or they are unable to reach up to the product level, and that's why the patent is not having that kind of weightage related to the commercialization. So whatever the content that you presented in today's webinar, sir, definitely it will help to the student as well as faculties to lead the innovative idea towards the a successful product which will be considered for the commercialization. I'm really thankful to you once again,